Hello, this is going to be the last lesson in our study of limits, in this topic of limits. This is the last lesson, and we are going to study what we call the intermediate value theorem. In short, we can call it the IVT. In calculus, we are going to study so many different theorems, which you have to use. But in the topic of limits, this is the only theorem that you will be using so much in calculus, and it is also very important because you will use it a lot. So, let us recall the properties of continuity that we studied in the previous lesson. If a function f and g are continuous at a, and if c is a constant, then the following functions are also continuous at the point A. So these are the properties of continuity. If you have any two functions, f and g, that are continuous at A, and some value c is a constant, then the following functions are also continuous at the point A. The function f plus g will also be continuous at A. The function f minus g or g minus f will be continuous at A. The function c times f, where c is a constant, will be continuous at A also. And f times g will also be continuous at the point A. And finally, f over g or g over f will be continuous at A, provided that the denominator is not equal to 0 at the point A. So, you will see in calculus that some functions will always be continuous in their domains. This is a review of something I talked about already in class. All polynomials are continuous in their domain from negative infinity to positive infinity. All rational functions, that is p of x divided by q of x, are continuous in their domain. All root functions are continuous, that square root of some function, are all continuous in their domain. And all trigonometric functions are continuous in their domain. For example, cos x is continuous from negative infinity to positive infinity. Sin x is also continuous from negative infinity to positive infinity. And tangent of x is continuous from negative pi over 2 to positive pi over 2, not included. So what does the intermediate value theorem therefore say? The intermediate value theorem, you are required to understand it, not memorize how to state it. It says that suppose that a function f is continuous on the closed interval a, b. If a function is continuous on any closed interval a, b, and let n be any number between f of a and f of b. Let this n be any number that lies between the value of the function at a and the value of the function at b, where f of a is not equal to f of b. In other words, the value of the functions at a and b are different. Then there exists a number c between a and b such that f of c is equal to n. This may sound not very nice, but it's very useful in calculus. Let's illustrate this. If you have the function that you have here, say you have this point A, this is f of A. You have a point B here, that will be f of B. And if there is some number n that is between, then it means that there must be a value of x that will have f of x equal to that n. That value is c. This is another sketch here. Let's say you have a is some value here, and b is some value here such that f of b is there. Remember, f of b cannot be equal to f of a, because if f of b is equal to f of a, then it's just the same value in the function. Then there will be no n between them. So because f of b and f of a are different and there is some number n, any number n between f of a and f of b, there will be some number, at least one number c, the value of x, at which f of that c will be equal to n. Remember, the function must be continuous from a to b. It says here the function must be continuous from a to b. Okay, let's see how useful this theorem is. Let's say that you want to show that there is a root of the equation 4x cubed minus this equals 0 between 1 and 2. There must be a root between this. This means that there is a value of x for which this is equal to 0. So what we can do here is let this function here be equal to f of x. And this will be our a and b. Because a root means that f of c will be equal to 0 at some point. So we have to prove that between a equal 1 and b equal 2, there is some point at which the function is equal to 0. So how can we prove that? We just use our calculator. We can just use our calculator. We have the function f of x there. Let me turn on my calculator. This is f of x, the value of the function that we have there. And what we need to do here is find f of 1 and f of 2. So we would use table function. Or we should set our table to ask, so that we input the two values. Okay, that's our table. So we'll find f of 1. F of 1 is -1. We will also find f of 2. F of 2 is 12. You see that f of 1 is negative and f of 2 is positive. So f of 1 is negative and f of 2 is positive. Because this is a continuous function, for it to live from -1 to +12, it must pass through 0. Right? So that's our argument. I have to then explain that f of 1 is positive and f of 1 is negative and f of 2 is positive. Because this function is continuous from 1 to 2, therefore it must pass through 0. To go from negative to positive, it must pass through 0. Okay. In AP examinations, you will see questions like this one here. These are the kind of questions you will have in AP examinations. And what is this question saying? It says that Rachel rode a stationary bicycle. Somebody was riding a stationary bicycle, just making the wheels turn. The number of rotations per minute of the wheel of the stationary bicycle at time t during Rachel's ride is modeled by this function, r. So this is the function, number of rotations per minute from t equals 0 to 9. The values of r for selected values of t are shown in this table. Now, you are asked, is there a time t for which r of t is equal to 106? If you look on this table, you don't see 106. But you would certainly know that 106 will lie between 95 and 100 12. Also, 106 will lie between 112 and 77. Remember, the question says you should justify your answer. Because number of rotations per minute is continuous, it has to start from 0 and then increase to some value. It is a continuous function. So we say that because R of 3 is 95 and R of 5 is 112. And then we say that this 106 is between 95 and 112. So we would say that 95 is less than or equal to 106, and this is also less than or equal to 112. Because this function is continuous and 106 is between 95 and 112, so there must be some value of t for which R of t will be 106. Therefore, there is some value of t at which R of t is 106. You can also justify it using R of 5 and R of 6. Remember, whenever it says justify your answer, you must show these values, these calculations here. You must show. It's very easy, but you must show them. You only have to show that this is a continuous function. It is a continuous function because the number of revolutions is a continuous function, and the R of 3 is less than 106 and R of 5 is greater than 106. Therefore, there must be some t at which R of t is 106. Okay, there is a worksheet below this video. Please download it and solve. Thank you. Remember, you will have a question on the IVT in your examination. Thank you.